Hello, and welcome to the R.E. Purvis and Associates training seminar on the ASTM D2000 rubber classification system. Today I'll be explaining the system and walking you through a few examples of how the system can be used to create specifications for rubber products used in the sealing industry. While the ASTM D2000 classification system is intended to be used by automotive companies, it is embraced by many other industries that use rubber materials. The key elements of the ASTM D2000 spec is that it breaks down all rubber materials by two defining characteristics. Those two characteristics being the resistance to heat aging and the effects on the rubber as a result of heat aging on tensile strength, elongation, hardness, those elements, and the resistance to swelling in oil. Some rubber materials will swell a great deal in oil, while others are very oil resistant. Those are both important elements in the classification of a rubber material, so they are the key two characteristics that are used in all rubber specifications. As you can see in Table 1 and Table 2 at the bottom of the slide, the temperature ranges and volume swell are broken into categories, temperature by roughly 25 degrees Celsius increments. Volume swell varies, starting at 10% increases and escalating from there. The two-letter combination breaks down which material family can be used for that specification. So when we start to look at the body of an ASTM callout, you'll notice there's a lot of alphanumeric information. We're going to look at this M3CH720 callout as our example as we walk through the meaning of each of the elements. The first piece is the M. And you'll notice the M starts the callout, and you'll see an M on almost all callouts that are from modern specs. Anything without an M was specified prior to 1980 and therefore is outdated. The M just simply means it's current, and all of the units involved are SI units. So you'll see things like Celsius, and instead of inch pounds, you'll see megapascals, things like that. The next element of a spec is a number, and it's going to designate the grade of material. As it says, grades can fall between 1 and 8, but a grade 1, grade 2, grade 3 are not an order of quality. Grade 1 simply means that the first part of the designation is sufficient and no additional classification or tests are required to specify the material. Grades 2 through 8 have different meanings depending on the letter callouts, and they just basically signify which tests can be applied and what results need to be. Each letter combination in the standard will provide which grades are applicable, and that helps make that determination. It's a bit of a nebulous concept, and it's a little hard to kind of explain in a brief tutorial here, but if you look at the standard, it makes the case fairly clear. Following the grade, you're going to have two letters. These letters tie back to the earlier explanation I was giving about temperature and swell. So in the chart I showed earlier, you'll see a list of temperatures that the material has been tested to, and that's the first letter. The second letter ties to the swell table, and that gives you the combination of temperature and volume swell for the material you're looking for. Well, you could invent a new material that uses any letter and number combination. Most standard materials have already been classified and broken down. So the standard does provide a list of common letter combinations and the associated materials. What this does leave out is a few ambiguities, however. So instead of having Ca, which is ethylene propylene, but also Da as ethylene propylene, and Ba as ethylene propylene, obviously the A is a consistent element for the swell, but the temperature can have a variety of ranges. So we can break it down a little further and a little neater. So if we look at some of the predetermined letter codes for materials, we can start with NBR or nitrile, which is a very common sealing material. We've got Bg and Ch, which are both predetermined to be nitrile compounds. B specifies a 100 degree C test limit, and C is 125. Now, with nitrile, you'll also see that the swell variation shifts a little bit based on temperature, with the lower temp allowing a bit more swell than the higher temp. Now, if we move on to HNBR, that would be a DH letter combination, which would be 150 C, and a similar swell rating to the CH nitriles. Now for EPDM, as I was saying earlier, we have a very common swell amount, but we have a bunch of different temperature ranges that are acceptable, ranging from 70 C up to 150 C. The A designation for swell is the highest allowable amount of swell. EPDM is notoriously bad for oil resistance and will swell considerably when exposed to oil. Moving on to fluorocarbon, you'll see that we have an H rating, which is 250 degrees Celsius, and a K, which is only 10% swell. So very stable in oil, but allowing for a very high temperature. Silicone similarly goes very high at 225 C, but allows for a bit more swell at 80% at the E rating. Fluorosilicone, once again, very high at 200 C, and a similar swell rating to fluorocarbon at 10%. Neoprene, much lower temp material, down at 100 degrees C, and allowing for quite a bit more swell as well at 100% swell in oil. And again, there are many other letter combinations that are used for other formulations, but these are the most common used in the sealing industry. Following the two letters designating temperature and swell, we get 3 digits. The 3 numbers represent 2 different elements, the first being the hardness or the durometer of the material. The first digit is multiplied by 10 to give you the resulting shore A durometer of the rubber you're specifying. In the 720 case, the 7 would mean 70 plus or minus 5 durometer. The second 2 digits reflect the minimum tensile strength of the material in megapascals. In the case of a 720, that would mean that the minimum tensile strength of the material would be 20 MPa. While the elements we already discussed are enough to specify a grade 1 material, in this case M3CH720, sometimes additional tests are required to ensure that the material being specified will meet the unique application requirements. In the case of this example, we've got a heat test with the A rating, a compression set with the B, and we've got 2 EO, which is oil resistance tests that are performed as well. These tests are specified by a letter designating the type of test, or 2 letters in some cases, followed by a couple of numbers. The first number specifies the test method in a case where there are multiple test methods available for that type of test. The final digit, or in some cases 2 digits, specify the test temperature. Unfortunately, that's going to be a little different than the test temperature in the letters earlier, because some tests require negative temperatures for a cold resist test, or different temperatures than the original heat specification of the material. The ASTM D2000 specification ties into many other ASTM tests to help specify the material to different application parameters. You'll see here, as we saw in our example, heat resistance, compression set. EO is a fluid resistance to oil and lubricants. There's also fluid resistance to fuels, to water, ozone resistance, low temperature resistance, and some other specifications that you won't see as often in the sealing industry, but because this is an automotive spec will make a lot more sense, such as adhesion, abrasion resistance, flammability resistance. They do come into play sometimes for seals, but are not very common elements when you start looking at rubber callouts for the sealing industry. The final element of an ASTM callout are the Z callouts. A Z is used when no other test really can cover the requirement that's being used. Very commonly, they're used to specify half increments on durometer. For example, fluorocarbon is very commonly used and formulated at a 75 durometer. A 7 in the spec would specify 70, so using a Z callout and then laying out that specifies 75 durometer instead of 70 durometer is very commonly used. Other common uses for a Z callout are specifying color, specifying special packaging, unique tests to your application. For example, some rubbers do not work well with certain plastics, so a test certifying the material to compatibility with a mating surface is a common use. Any additional requirement or internally created test can be specified as a Z callout, but must be specified alongside the ASTM spec on any drawings or other material control requirements. If the instructions for the Z callout are missing, it must be ignored. So now that we've gone through our first example, let's take a look at another callout that we've pulled from a customer print. In this case, we've got an M2 HK710 with an A1-10 test, B37 test, B38 test, EF31, EO78, and 2 Z callouts. Now you'll note this does correctly specify the 2 Z callouts, Z1 being 75 plus or minus 5 durometer, and Z2 being the color brown. So let's break this into its elements and take a look at them. So let's break this down. M2 HK710 is our general information for this material. M means SI units. We can generally ignore it. We just know that it is a current spec. 2 is our grade 2. That'll tell us what the requirements are for each of the individual tests that are to follow, and that it's not a grade 1 material, saying that we don't need any additional tests. H and K are our temperature for tests and our swell rating. We can see that H corresponds to a 250 degree heat age test, and K represents a 10% max swell in IRM 903 oil. 710 is our durometer and our tensile strength. 7 is telling us 70 plus or minus 5, and 10 is 10 megapascal minimum tensile strength. Now we also remember that one of those Z callouts was telling us it's actually 75 durometer. So in this case, the Z callout is superseding the 70 durometer specified as part of the general line callout. Getting to the additional test specifications, we start with an A callout, which is a heat age test. We have a A1, meaning it's heat age using method 1, and -10 is telling us it's 250 degrees C. The B37 and B38 are both compression set tests using method B at both 175 and 200 C. Finally, we have a pair of fluid resistance tests. First, EF, which is a fuel resistance, with the number 3 specifying that method 1 is to be used at 23 degrees Celsius, and EO, which is an oil resistance fluid test, using method 1 again, designated by the 7, at 200 C, designated by the 8. The test requirements and methods are all laid out in the standard, but vary wildly depending on the test. So it's hard to have a comprehensive listing of which number refers to which method without delving into each of the specific tests. I want to thank you for joining us for this training today. I realize we covered a lot of ground in a very short time, and you likely have questions. If you do, I'd like to invite you to reach out to us either through the comments here or emailing our talented sales staff at sales@repurvis.com. Or please visit our website and utilize our online chat feature, or reach out to us through our Contact Us form. Thank you. And if you have any suggestions for other videos on topics related to sealing that you'd like us to cover, please feel free to mention it in the comments. Thanks.